This is part 2 of Unit 5, Lesson 1, Mean Value Theorem. We're going to continue with examples of how the mean value theorem is used. So example 2, let f be the function given by f of x equals x squared plus 2x minus 3. Find the number c that satisfies the conclusion of Rolle's theorem for f on the closed interval -3 to 1. Okay, so what we want to do is start with our conditions for Rolle's theorem, which are that the function has to be continuous on the closed interval and differentiable on the open interval. So that's the first thing I'm going to do here. So number 1, I'm going to say f of x is continuous. That looks like an A, not a U. Continuous on the closed interval, -3 to 1, and differentiable on the open interval, -3 to 1. And I can say this because f is a polynomial. Then what I'm going to do is I'm going to take the derivative. So f prime of, I'm sorry, hit my watch again. I gotta stop wearing that. Why I do these. Okay, then what I'm gonna do is I'm gonna check the endpoints. I need to see if f of -3 equals f of 1. That's a condition of Rolle's theorem. So I have f of -3 is gonna equal 9 minus 6 minus 3, which is 0. And f of 1 is going to equal 1 plus 2 minus 3, which equals 0. So the endpoints are equal. Now I can take the derivative. F prime of x is going to equal 2x plus 2. And by Rolle's theorem, that means that f prime of x is going to equal 0. So 2x plus 2 is going to equal 0, and I'm going to get that x equals -1. And that's my C. And we're done with that one. Okay. A sports car speedometer registers 50 miles per hour as it passes a patrol car stationed at a mileage marker. 4 minutes later, the car passes another patrolman at a marker that is 5 miles from the first. So we have a distance of 5 miles between the two markers. The driver notes that the speedometer registers 55 miles an hour. Can the highway patrol use the mean value theorem to prove that the driver was exceeding the speed limit of 70 miles per hour at some time between the two mileage markers? So we know that all of our police officers are using calculus out there, and they have the mean value theorem, so be careful about speeding. So here are our two mileage markers, and the vector is going to represent the distance in between them, and t is going to be the elapsed time. After passing the first marker. Or you could say the officer, because he's at the first marker. Okay, so, and just to label this a little better, S of t is the distance. Okay, so that's what we're looking at here. So the other thing we want to notice is that our mileage is in miles per hour, but our time that was given is in minutes. So we got to change 4 minutes into an hour. 4 minutes becomes 4 over 60, which is, that is not 60, that is 16. 4 over 60, which becomes 1 over 15. So 1/15 of an hour. Okay, so now Mean value theorem says that I can find the average velocity by taking the value at 1/15 of an hour and subtracting that by the value, the distance at s over 0, and then the distance between them. 1/15. Okay, so our averages, so they are 5 miles apart, so that's 5 over 1/15, and when I simplify this, I get 75 miles per hour. So yes, by the MVT, the second car was exceeding the speed limit. So that's what they're doing in their patrol cars. When you think they're just sitting there on their phones, they're actually using calculus. All right, number 4. Let f of x equal 5 minus 4 over x. Find all values of c in the open interval 1, 4, guaranteed by the mean value theorem. Okay, so what we can see is that we always want to start by saying the conditions are met, that our function, f of x, is continuous and differentiable that's supposed to be an O. I am having real trouble spelling today. I apologize for that. Okay, now the reason why we can say this, even though this is a rational function, is because we're excluding the part of the graph here before 1 where it has a vertical asymptote. So on the interval we're given, we have that. Okay, so what this is saying is our mean value theorem is we are going to say that the slope of the secant line between the endpoints has to be equal to the derivative of the function at a specific point. And that derivative is going to be 4 over x squared. Okay? So filling this in, looking at our graph, so we're doing this point, 1, 1. And at 4, we are at 4, 4. Pretty simple. So we're doing 4 minus 1 over 4 minus 1. So we get 1. And that has to equal 4 over x squared. So we can find two values on our interval. So if we solve this then, we have x squared equals 4. So x is going to equal 2. So c is going to equal 2. Now I know there could be two values here, but remember our interval is 1, 4. So at c equals a 2, there's a value where the average rate of change is equal to the instantaneous rate of change, and that is going to happen. Is going to happen at x equals 2 or c equals 2. It's at that point right there. So if we were to draw the secant line, what we would find is that our tangent line is going to be parallel right there. So that's what that's telling us. Okay. So remember that the MVT allows us to identify exactly where graphs rise or fall. So you can tell that functions that have positive derivatives are increasing functions, and functions with negative derivatives are decreasing functions. Example 5. Find all the values between the x-intercepts for which Rolle's theorem holds for the roots of f of x equals 4x squared minus x to the 4th. Verify with your calculator. Okay, so what we're going to have in this case is, again, we can see that f of x is continuous and differentiable everywhere. because it's a polynomial. So I don't know what those boundaries are going to be yet, that interval I'm going to use, but I can find it now. So what we want to do is we want to first find the x-intercepts. So I should write here Rolle's theorem applies. Well, it's going to. I'll get to that in a second. I'm getting ahead of myself. Because I need two endpoints that have the same y value, and I'm going to get those from the x-intercepts. So I'm going to take my function and set it equal to 0 to find the x-intercepts. So I have x squared times 4 minus x squared. So I have 3 x-intercepts. I have 0, I have 2, and I have -2. Okay. So just taking the two extreme ones, what I know now is that f of 2 equals f of -2, which is going to equal 0. So Rolle's theorem applies from what I've written. Because I already said it's continuous and differentiable. So now what I can say is that f prime of x is going to equal 0 sometime in that interval. And if I take the derivative, what I get is I get 8x minus 4x to the third is going to equal 0. So factoring this, I get factor 4x out. I get 2 minus x squared equals 0. So I get x equals 0, which I already had because it was a third root. And then I get x squared equals 2, so I get x equals plus or minus the square root of 2. And these are known as your critical numbers. And we're going to talk about that more in the next section. Okay, so now I need to pull up my graphing calculator and verify this. And putting my function in, I am going to say that I have 4x squared minus x to the fourth. And I'm going to hit zoom 6. And here comes my polynomial. There we go. And you can see that because the graph looks like this, there are 3 places between -2 and 2 where the tangent line will be horizontal. One is at the third x-intercept, which is 0, and since it's a symmetrical graph, the other 2 are at negative square root of 2 and positive square root of 2. So if you want, you could trace this graph and see that. So I can put in for x square root of 2, and it'll take me right there to have a horizontal tangent line right there, and the same thing with negative square root of 2. Okay. All right, and our final example. Determine whether g of x equal to sine 2x plus 2x satisfies the hypothesis of the mean value theorem on the closed interval 0 to pi. If so, find number c in the open interval ab such that g of b minus g of a is equal to g prime of c times b minus a. So first, satisfying the conditions of the mean value theorem, we can say that sine of x and 2x are continuous and differentiable everywhere. Yep, spelling is not my strong point today. Come on. No, I'm having pen issues. So that's one thing. I'm good. So you can say, therefore, g of x is 2. Because it's the sum of 2 continuous functions. So the next thing I'm going to do is I'm going to put my endpoints in, and I'm going to get g of 0 is going to be sine of 2 times 0 plus 0. So I get sine of 0 is 0, so I get 0. And g of pi is going to be sine of 2 pi plus 2 pi. So I get 2 pi. And now I'm going to take the derivative. G prime of x is going to equal 2 cosine of 2x plus 2. Okay, so now we're going to use the mean value theorem. And we're going to say that g of pi minus g of 0 over pi minus 0 has to equal my derivative. That's what the mean value theorem says, because that gives you the slope of the tangent line. So I'm going to have 2 pi over pi is going to equal 2 cosine 2x plus 2. So let me come up here now. Let me change color so it's a little easier to see. The pi's will cancel. So I have 2 equals 2 cosine 2x plus 2. Subtract the 2. I get 0 equals 2 cosine 2x. I can just get rid of that 2. So I am looking where cosine 2x equals 0. Okay, so what angles in 0 to pi would help me out with this? So 2x is going to equal 0 if I just do the whole unit circle, and then I can see where they are in my interval. Is going to be 0 at pi over 2 and 3 pi over 2. Now solving for x, I'm going to divide it by 2. So my two x's are pi over 4, and my other x is going to be 3 pi over 4. That's why you need to check this one, even though it's not in my original interval, because that's where 2x is equal to 0, cosine of 2x, but I just want where x is. So those are my two x's. So c is going to be equal to pi over 4 and 3 pi over 4 on my closed, that's supposed to be an O, on my closed interval 0 to pi by the mean value theorem. Okay, and we'll continue our discussion in class next time. So if you have any questions, I'll answer them then.